A zero matrix is any matrix that has all zeros for entries. So for instance, we would have the 2 by 2 zero matrix that looks like this, or we could have the 3 by 1 zero matrix, which would look like this. And because both of these are zero matrices, to distinguish between different zero matrices, we often use the dimensions. So we always call the zero matrix capital O, not a zero, but a capital O, and then we put the dimensions. So this would be the 2 by 2 zero matrix, and we would write that as capital O and then 2 by 2 as a subscript. This would be O 3 by 1, the 3 by 1 zero matrix. And this should be all pretty intuitive, but adding the zero matrix to any other matrix doesn't change the value of the matrix that we're adding to. The dimensions still have to be the same because it's matrix addition. But for instance, if I'm adding this to 1, 2, 5, the result will just be 0 plus 1 gives me 1, 0 plus 2 gives me 2, 0 plus 5 gives me 5. So of course, adding the zero matrix doesn't change the value. If I subtract the zero matrix from another matrix, as long as the dimensions are the same, then the subtraction is defined. But of course, the value is not going to change. Here I have 1 minus 0 gives me 1, 2 minus 0 gives me 2, 5 minus 0 gives me 5. So subtracting the zero matrix doesn't affect the value. The most interesting thing related to zero matrices are what we call opposite matrices. And opposite matrices are two matrices that, when we add them together, they give us the zero matrix. So for instance, let's say here that I have a 3 by 2 matrix. We'll say 1, 4, negative 2, and 0, 1, 1. And let's say that this is matrix B. So we'll say B. Well, to get B's opposite, I just multiply B by negative 1. So I'm going to multiply both sides of this equation by negative 1. And when I do, over here on the right-hand side, I'll get negative B. On the left-hand side, I distribute negative 1 as a scalar across the entire matrix, and I'll get negative 1, negative 4, 2, 0, negative 1, negative 1. In other words, all of the signs just change. So now we have this matrix B and this matrix negative B. The matrices B and negative B are opposite matrices. The matrices K and negative K would be opposites, L and negative L would be opposites. So that's how you recognize opposite matrices. So let's see what happens when we add those opposite matrices. So when I add 1, 0, 4, 1, negative 2, 1 to its opposite, which is the matrix negative B. So I have negative 1, 0, negative 4, negative 1, 2, negative 1. And this is B plus negative B that we're adding. What do we get here? So we get 1 plus a negative 1 gives us 0. 0 plus 0 gives us 0. 4 plus a negative 4. 1 plus a negative 1. Negative 2 plus 2. And 1 plus a negative 1. So of course, as we expected, as we said, we would get the zero matrix. So I'm always going to end up with capital O here, the zero matrix. And that makes sense here because if we look at this, we have B plus a negative B. That's the same thing as saying B minus B. And as we saw before with matrix addition and subtraction, if we just take B minus B, we're of course going to get a matrix full of zeros, or the zero matrix.